In this video, we'll be looking at system life cycles. A system life cycle describes the life of a system everywhere along the line, from its original inception and design and need for the system right through to its retirement when the system is no longer required. So the life of the product, the life of the system, isn't just while we're using it as an operator. There's something that happened before. There's something that will happen after. It has a beginning and an end, just like everything else we see in the world. Even if the end in this case is it sits in the corner of a room and isn't used for decades until someone realizes, oh, this is rubbish and we can throw it out. So we have different life cycle phases, and different textbooks will use different phases. These are four that are commonly used, and they're used within our textbook and summarize a lot of the different phases that are listed in other places. So we start off with the pre-acquisition phase, we move through to the acquisition phase, the utilization phase, and then the retirement phase. And these are sequential, so one after another in this order. So let's go through a summary of basically what happens at each of these phases. Firstly, we have the pre-acquisition phase. And this is where we essentially establish the need for the system. Management and executive management might say, we've got this particular issue, we need to do something about it. We need to develop a system that will solve this particular issue for us. And then we come to the acquisition phase, where we're doing the major planning, construction and systems design, and actually designing and building the system. In the utilization phase that follows, we then put the system into action and actually use the system, and that's where things like maintenance is performed on the system and maybe some software upgrades and things along the line. But primarily that's where we're actually using the system. And at some point, the system will be removed from service. So it will be retired in some way. Now that retirement may mean it's sold onto someone else. If it's a piece of hardware that someone wants to use, it might be scrapped. Parts of it might be recycled. Who knows what it is, but at some point it will be retired. So a bit more detail on each of these phases. The pre-acquisition stage is where it all starts. Now, this is where we identify some sort of a business problem that we want to address. Now, who knows what that business problem is? It might be we need a new system for printing, or we need a new system for sharing documentation, or we need a new system which involves transportation, or some sort of a new system related to machining or wordjet cutting or something like that. So here we have the idea of a system, the inception of a system to solve some sort of a business problem. And it's typically stated in business sort of terms. These are our business needs and requirements. And so we establish those business needs and weigh them all up. Things like the cost of it, the time that it will take to do it, the actual benefits involved. And based on that, we ask the question, should we proceed? Is it feasible? Will it actually be worth it? In business, lots of people throw up lots of different ideas, and some of them are probably not worth it. Some of them might be great ideas, but some of them will be rubbish, and we shouldn't actually proceed with them. So we should have a structured approach of actually identifying these ideas, thinking about these ideas, and evaluating them and working out whether we move on to the next stage of trying to acquire something like this. Some of these ideas might become white elephants. It essentially costs so much to keep the idea going and keep the system going, it's really not worth it. Our next stage is the acquisition phase. And here we're actually building a system and bringing it into service. So this stage, we've worked out all the requirements are and completed the requirements listings and things like that. And they've been supplied to those designing the system, our contractors generally. We have two different options though. We have a third-party contractor that could be designing the system, or it could be designed by an in-house design team if the company has expertise in this particular area. We then have our utilization phase, and here is where the system is actually in service and providing the value and benefit that it was designed for to begin with. In this operational phase, there's a few things that might occur. For example, we might change our needs and requirements, or we might identify new needs and requirements. Often it's the case that someone else will see the system working and say, oh, will that system do this? And say, well, yes, or almost, with a few tweaks it might be able to do that. Well, maybe our external environment changes. There might be new laws that are passed in Parliament, or new regulations that are imposed on a company or on a system. There might be changes like the company actually moves to a different premises. There's all sorts of different environmental changes that could occur. Might be a new boss, might be new staff. And then another thing that might occur is we identify specific shortfalls in the system. And these could be in a huge amount of different areas. Things like reliability, cost, it costs too much to maintain. Performance, usability, security, we find flaws in the system. And at this point, we might perform several things, for example, modifications to the system, upgrades, patches, redesign. And if it's in-house, well, we might get in-house people to work through these things. If it's a third-party contractor, we might go back to them and say, we need a modification to the system. Can you please quote us on this and provide this modification for our system? And then comes retirement. Nothing in the world lasts forever, and neither do our systems. Now, there's many different reasons that we might retire a system. It might not be cost effective to run this system anymore. It might actually cost more to run this system than the benefits providing, or possibly new models of this sort of system have come out that are a whole lot cheaper to actually run. This system might be obsolete and might use technology that was in vogue 20 years ago, but is not actually all that useful today. We don't see a whole lot of computers around today with floppy drives and things like that, and only a few kilobytes of RAM memory, or a few megabytes for that matter. We're talking, my computer at the moment's got 32 gig of RAM in it. We've got huge amounts of, particularly in the high-tech environment, huge amounts of equipment that will become obsolete over the next few years or decades at the long point. We might not actually need the system anymore. This business might not be operating in that area, or maybe the person or people that were operating that system, they might not be around anymore, and there might not be a role that's actually being filled there. And our business needs and requirements may have changed. We may set the business in a different direction, or there may have been a restructure, and our business might not actually do that thing that the system was specified for. The system might also become inoperable and unrepairable, or very expensive to repair. In that case, it might be cheaper to scrap it and buy a new one than try and repair the whole thing. Hopefully, what we've done at the onset, though, is design our system so that we can actually retire it fairly easily and in a cost-effective manner. So let's go through a couple of examples of system life cycles for particular products. And firstly, for a car. So in our pre-acquisition phase, we might have a manufacturer identifying a particular market for a car, a people mover, a sports car, or that pre-acquisition phase might rest with a business. They say, we need a car that can do this. It has this many cubic meters of storage and this sort of suspension and these sort of things. Then during the acquisition phase, there's the design of the car for its intended conditions. Now, these days, think about it, we don't go to a manufacturer and say, I need a car that can do this, can you design this for me? In the military, they might do that for a tank or an aircraft or something like that. But essentially, for a car and for the sort of environment that we're working in, we look at what's out there, we look at what's off the shelf and say, does this tick the boxes? And yes, this ticks the boxes for me. But the company that designs the car will actually be evaluating those things as well. What do people actually want? What are their needs and requirements? That car's then sold to the public, and there's regular and scheduled servicing and maintenance of the car and distribution of spare parts and all those sort of things. So it's not just the car, there's all the infrastructure around that car. The spare parts, dealerships, service, logbooks, all those sort of things. And then we have retirement at some point in time. Will we sell it? Will we repair it? Will we recycle it? Will we buy another car? Will we trade in that car and get a different car as a replacement? Now, something on a bit larger scale. New system life cycle for a nuclear power plant, for example. In our pre-acquisition phase, we'd be looking at the needs and requirements. So investigating the need for a power plant and determining the project's feasibility. So what are our issues? We need reliable power, we need baseload power on this sort of scale. We'd be looking at places that we could actually house this and all the infrastructure that's required around it. We then have our acquisition phase where we design or use some sort of an existing design that someone else has designed and we gain all the sort of approvals, environmental approval, finance approval, governmental approvals and things, and we move towards the construction and actually construct this thing. During our utilization phase, we then actually generate the power and perform maintenance and all the safety regimes and things that would be required in this sort of product. And of course, treatment of waste material and storage and whatever else may be involved. And at some point, we'll probably retire this. And so there will be a decommissioning process, probably some sort of a demolition and deconstruction of the plant and decontamination of the area and remediation of the area back to something that is within environmental controls and limits. Well, one thing that we need to remember, and this is a graph that we'll see several times throughout this course, is the cost of changes and changes in requirements throughout a system. And this is one of the beauties of system life cycles and systems engineering. The earlier that we specify things and the earlier that we get all our requirements sorted out, the earlier that we sort all these things out, the cheaper it is. The later that we do those sort of things, it becomes very, very costly to do. And so we want a whole lot of this sort of stuff at the start of the process and get our requirements and things right, not leave it to the end where it becomes very expensive. And that's the beauty of systems engineering. So why are system life cycles important? Well, it gives us a whole of life approach. Our system, for example, might contain very inexpensive but dangerous or toxic material, which may make retirement very, very costly. We also need to think of, can it actually be delivered? It might be better to split up areas of the system and deliver the system in stages, or think about these things on a grander scale rather than having someone's doing this system over here and this system over here and this system over here and having none of them communicate to each other. If we're going to develop several systems, we should make them interoperable so that they can actually work together and not work against each other. And we need to think about things like maintenance that's required throughout the life cycle of the system. Vehicles are a great example of the sort of maintenance that we're requiring. They have logbooks and they say this is the maintenance that you need and this is when you need it, and you book it into your dealership there. And all the equipment that we have, our milling machines and wordjet cutters, we have scheduled maintenance of when it's going to be pulled apart and cleaned out and parts replaced, and all those sort of things are prescribed based on design. There's all sorts of things as well. If we find a defect in a vehicle, we need to perform recalls or repairs. That can be very, very expensive and costly if found at the utilization phase. If we find these things as defects, particularly if they're defects in design and not meeting the requirements of where it's going to be used in the system, if we can do that at the acquisition phase by getting the requirements right and getting the validation and verification right, it becomes a whole lot cheaper. We don't bring people in and say, bring your cars in, and lose the brand reputation and things of having to fix all these issues that have occurred. So for example, in the case of a nuclear power plant, if our design wasn't actually compatible with the fuel rods that are available to us, we might need further design and construction work to do something. If our fuel changes at some point, well, we should be knowing the sort of trends and things in the industry that are happening so that doesn't completely catch us by surprise. We don't want to design something on a technology that will soon be obsolete and unavailable. And where we're doing electronics and using components and things, often we'll look on some of our websites, Element 14 or something like that, and they'll give warnings saying this particular device will become obsolete in 2 years or in a year or something like that, or recommended not for new designs. That means we don't actually design it into our product that we'll be producing millions of things of, because we won't be able to buy it soon. We'll have to redesign our product sometime in the future. One thing that we also need to think about, particularly in things like a nuclear power plant, if we didn't account for the cost of decommissioning and retirement, this could end in financial ruin. There's also massive costs in things like mining, where we need to retire mines and restore the land. These things can cost millions, if not billions of dollars to do. If this wasn't actually in the business plan and in the system life cycle, this is where people go to government and with their hand out saying, can you please help us out and bail us out here? It's a real issue, and a real issue of there's actually money involved in retirement. This just doesn't happen by itself. You can't just leave these things as a ghost land. You need to retire it. Otherwise the EPA starts coming after you. And so in conclusion with system life cycles, they're critically important to design them in a way that addresses all stages of the life cycle, not just the utilization phase or not just the acquisition phase. You need to do the whole lot from our pre-acquisition to our retirement, and that gives us our cost-effective solution, our solution that will actually solve the problems for the whole of life of the system, not just for one segment of it.